Oh, welcome back, everyone. Let's continue with the investigation of finite differences and quadratic relations, our first degree polynomial functions. So in this case, again, we have chosen values of x that are increasing by 1 unit, some negatives, some positives, and 0. And we'll start off with finding the y values of a general equation of a quadratic form. Now, when x equals -2, we're going to find that the y value is equal to, let's make this as big as we can, a times -2 squared plus b times -2 plus c. Simplify, -2 squared will make a positive 4, so that's 4a, b times -2, -2b plus c. Next we have x equals -1, so a times -1 squared plus b times -1 plus c. That will give a minus b plus c. Next we have x equals 0, a times 0 squared plus b times 0 plus c. And that will give, remember, multiplication by 0 will give 0, and that will give the constant term c. Now, if x equals 1, we have y equals a times 1 squared, b times 1 plus c. That will be a plus b plus c. And lastly, we have x equals 2, so a times 2 squared plus b times 2 plus c, and that would be 4a plus 2b plus c. So these are the y values we obtained. I will highlight them so they're easier for us to spot as we use them to find the first differences. So we're going to start off with finding the first differences. Remember that we are subtracting the previous term from this y value. So we're going to go ahead and subtract from a minus b plus c the previous y value. You see that there are 3 terms in here, so when you subtract more than one term, you got to keep them in brackets to ensure that every term is being subtracted correctly. So a minus b plus c minus positive a minus negative b will make positive 2b, and minus positive c minus c. So simplify some more. You see that the constant c will simplify to 0, so or will add to 0. We have a minus 4a negative 3a, negative b plus 2b is 1b. So next we're going to do the next set of the y values. So we have this time c. This is a little easier. And from c we are subtracting a minus b plus c. So we're going to keep that in brackets because there is 3 of them. So that's c minus a minus negative b, which is plus b, and minus positive c minus c. So notice how the coefficient c and negative c will add to 0, and we'll get negative a plus b here. So I'm actually going to place them somewhere in here so that it looks less crowded. Now we're going to do the next set of y values. So let's see what we got here. We get a plus b, trying to change the color here. So a plus b plus c, and we are subtracting the previous term, which is just c, and you can see that adds to a 0. So that would be simply a plus b. And lastly, we have the difference between 4a plus 2b plus c and a plus b plus c. So we're going to have to open up brackets here. Remember, subtract positive a, subtract positive b, subtract positive c. So c minus c adds to 0. We have 4a minus a, 3a. And we have 2b minus b is 1b. As you can see, delta 1 is not constant. That tells us that this is not a linear relation, and we're not surprised by it. We know it's a quadratic because we have selected it. Now, we'll continue with the second differences, which are the differences of the first. So this is the list of our first differences. We're going to find their second. They're found in the same fashion. So we have negative a plus b, and we're subtracting negative 3a plus b. So negative a plus b minus negative 3a plus 3a minus b would be negative b. You see that this time we have b and negative b, simplify or add to 0. Negative a plus 3a is 2a. Let's do the next set. We have a plus b, oops, and we're subtracting from it negative a plus b. So from here, we're subtracting the previous one. Now, a plus b minus negative a is plus a minus positive b. Again, b and negative b will add to a 0, and the answer will be a plus a, or 2a. So I see consistency happening already. And the last difference we're doing here is 3a plus b, and we're subtracting this time a positive a plus b. Now 3a plus b minus a minus b. b minus b adds to a 0, and 3a minus a is 2a. So as you can see, delta 2, or the second differences, are constant, and that tells us that the function is a second degree. So this is how we're going to draw the conclusions then. We're going to say that delta 2 is constant, which tells us that this is a second degree polynomial function. Now the next pattern that deserves attention is the value of delta 2. As you can see here, delta 2 was consistently equal to 2a, and we took a general equation in here. So we're going to say that the value of delta 2 will be double the coefficient a, the leading coefficient. So that will help us determine the value of coefficient a, which seems to be 1/2 of delta 2. Or in other words, we're going to say a is delta 2 divided by 2. Now, in order to find the equation of a quadratic function, we're going to need to know the coefficients b and c as well. So we need a pattern, or a way to discover some patterns in here between differences or the numbers in these tables to determine the values of the coefficients b and c. Now, as you can see here in the table of values, you see that c is sitting on its own as the value of y when x equals 0. And that was kind of similar when we were looking into the linear functions. So the value of y at x equals 0 will give the coefficient c, or the constant term. So we're going to say that coefficient c, which is the constant term in the function, would be equal to the y value at x equals 0. Now, obviously, we need information about coefficient b as well. And there are patterns that we can actually kind of use and discover in this case. But I think that the most practical one would be to simply use any point from the table of values and determine the value of b. So to find the value of b, and I'm going to write a note in here. So to find coefficient b, we use any ordered pair from the table of values. We substitute it into the equation, and that will give us the value of b. So we're going to solve for b. Let's take a look at an example and illustrate all the steps through an actual example. So here we're given a table of values, and we want to find the equation that is hiding behind this particular set of ordered pairs x and y. So we're going to start with our first differences. So for first differences, we're looking at the differences in the y values. And what we see in here are 0 minus 3, negative 3. 1 minus 0 is 1. 6 minus 1 is 5. 15 minus 6 is 9. And 28 minus 15 is 13. So they're not constant. Therefore, this is not linear. So we're going to move on to second differences. we find the second differences in the same fashion again. So we have 1 minus negative 3, that's a 4. We have 5 minus 1, again a 4, so that it seems that we have a pattern here. 9 minus 4 is 4, and 13 minus 9 is 4. So the second differences are constant. So we're going to say delta 1 is a constant number, which tells us that this is a quadratic or a second degree function. So that would lead us to the equation. So the equation is going to be in the form, so we should be looking for an equation of the form y equals ax squared plus bx plus c. Now let's think about how we are going to find all these coefficients. Remember that in quadratic functions, we say that a is 1/2 of delta 2. We said that c is y at x equals 0. So let's explore them. So delta 2 is 4. So that means that the value of a would be equal to 1/2 of 4. So 1/2 times 4, that will make a equal to 2. The value of y at x equals 0, here is x equals 0, the value of y is 1. That will give us the value of c right away. So therefore, we're going to say that c equals 1. So far, we have formed an equation that looks like this. Y equals, we have 2, we have x to the power of 2. We have b that we don't know yet, and it has an x attached to it, and then number 1. And now we have to find the value of b. For this, we're going to use an order pair from the table of values. And my favorite order pair to use is the one where x is equal to 1. And you will see that when x equals 1, it's a lot easier to simplify the right side of the equation. The y value, the corresponding y value here is 6. So we're going to rewrite that same equation. So we have the a value of 2. 1 is brought to the power of 2 plus b that we don't know. So we're going to leave it as is times 1 and then plus the value of 1 here. So as you can see, we have only one variable. So we have 6 equals 2 plus b plus 1, or 6 equals b plus 3, which will make the value of b equal to 6 minus 3, or simply equal to 3. So now that we got the value of b as well, we are going to say that we're ready to state the equation. And the equation of this function will be y equals, the value of a was 2, x to the power of 2, and then the value of b was 3, and then multiplied by x, and the value of c, which was equal to 1. You can write this function either in xy or function notation. It's the same thing. We have 2x squared plus 3x plus 1, and that would be the final answer. Now there is a second example for you to try on your own, and I will continue completing this as well. So we have this table of values represents what it seems to be a quadratic relation because we are talking about them. So let's find the first differences. So first differences would be 2 minus 3, negative 1. Then we have 3 minus 2. We can probably drop this because it's kind of obvious and easy. So 3 minus 2 is 1. 6 minus 3 is 3. 11 minus 6, that's a 5. And 18 minus 11, that's going to be equal to 7. Now we're going to do the second differences. So this time we have 1 minus negative 1. So that's a 2. Then we have 3 minus 1. That's another 2. And when we have 5 minus 3, it seems that we have a consistent pattern. That's a 2. And lastly, we have 7 minus 5. We'll do that as well. Why not? But it is obvious that the second differences are constant. So we're going to say delta 2 is constant, and it is equal to 2, which makes this a quadratic or a second degree relation. And the equation that we're looking for then would be in the form ax squared plus bx plus c. And now we're going to think what coefficients we can get in here. So remember that we said that the coefficient a is going to be 1/2 of delta 2, which will make it 1/2 of number 2. So coefficient a here is 1. Coefficient c is y value at x equals 0. So let's look at x equals 0 here. We have the y value equal to 3. That makes c equal to 3. So we're going to write our equation with the coefficients we have discovered already. So 1x squared plus bx plus 3. We're going to need to find the value of b, which we don't know yet, but we have our good friend here, 1 and 6, this ordered pair where x equals 1, that we're going to use to find the value of b. So when x equals 1, y equals 6, and we have 1 to the power of 2 multiplied by 1 plus b multiplied by 1 plus 3. As you can see, you have only one unknown. So 6 equals 1 plus b plus 3 or b plus 4. And we're going to say 6 minus 4 is b or b equals 2. You don't need that many steps, but I'm just trying to show all the possible work here. And we're going to say that the equation of this particular function described by this table of values will be 1x squared. We don't need to write that. And then plus b, which is 2x, and then plus c, which is equal to 3. And voila, this would be the answer for this function. Now, in the next video, we will explore the third-degree polynomial functions and follow for more. Thank you for learning with me, and bye for now.